Experiment 5. PCB Production. Part 1. PCB Plotter Settings. The aim of this experiment is to teach students how to produce a PCB board out of a given PCB layout design. This set of videos shows how to produce a PCB board for the 4-bit binary counter circuit designed in the previous experiment. The first video shows how to set the Promat S103 Plotter to print our circuit on a single-sided PCB board. To start the PCB plotter, open the cover and turn on the power switch located at the right side. Make sure to close the machine cover before running the plotter software. Next, run the Circuit Pro software, which controls the PCB circuit plotter. The software starts communicating with the plotter to determine the plotter type, firmware, plotter settings, and if there was an abnormal termination in a previous run. Then, the software will move the plotter head to the startup position and connect the camera. In the New Document window, click Load Default Template button to create a new project with default template. The prototyping toolbar allows us to make the prototyping settings necessary to produce our PCB board. The toolbar contains the following prototyping wizards: 1. Process Planning Wizard. 2. Import. 3. Rubout Area. 4. Fiducial. 5. Technology Dialog. 6. Tool Magazine. 7. Board Production Wizard. 8. Tool Library. We start by the Process Planning Wizard, which allows us to select the process type, the number of layers, and the type of substrate to be used. In the Process Type dialog, select Process PCB. In the Layers dialog, select Single-Sided Bottom. In the Substrate dialog, select the type of substrate to be used to produce the PCB circuit. In our case, we will select the FR4 type. Next, we will import the PCB layout files. In the imported file list, we need to assign the proper template layer for each file. For the bottom copper file, assign Bottom Layer Template. Assign the Board Outline template to the Mechanical Layout file. For the Drilling Layout file, assign the Drill Plated Layer template. Next, we set the Rubout Area, which defines the boundary of the regions where all unnecessary copper is removed from the PCB board. We can define the Rubout Area for all layers or just for the bottom layer. In our case, we will select Rubout Bottom. We can set the Rubout Area by drawing a rectangle around the region where all unnecessary copper is to be removed. Next, we set the fiducial points. Fiducials are optical marks on the surface of the circuit board that are used for aligning the circuit board. The fiducials are drilled into the board and are recognized by the cameras of the Promat systems. We need at least 3 fiducial marks. Next, we select the Rubout type and the counter routing type from the Technology dialog menu. There are 4 main Rubout methods. 1. The basic method. 2. The basic and double pads method. 3. The partial Rubout method. 4. The complete Rubout method. The basic method uses a single insulation channel for wires and pads. This method requires the shortest processing time during the PCB production, but it results in the least precise insulation. The basic and double pads method uses a single insulation channel for wires and double insulation channel for pads. This method requires short processing time, but it results in less precise insulation compared to the partial and complete rub-out methods. The partial rub-out method uses a single insulation channel for wires and pads, in addition to removing copper in defined areas. This method requires more processing time, but results in more precise insulation compared to the previous methods. The complete rub-out method removes all unnecessary copper. This method results in the most precise insulation, but it requires more processing time compared to other methods. In our case, we will select the complete rub-out method. Click the More Details button to explore additional settings of the complete rub-out method. From the rub-out drop-down list, you can select the layer that defines the boundary of the rub-out area. For example, if we select the rub-out bottom layer, then this will remove all unnecessary copper inside the blue rectangle, which was defined during the second prototyping step. On the other hand, if we select the board outline layer, then this will remove all unnecessary copper inside the board outline, which is the green rectangle. Contour routing defines how to cut the printed circuit board after printing is completed. The contour routing section offers 6 different routing methods. 1. The basic method defines a contour routing without gaps. 2. The horizontal gaps method defines a contour routing with gaps on front and rear side. 3. The vertical gaps method defines a contour routing with gaps on left and right side. 4. The edge gaps method defines a contour routing with one gap on each edge. 5. The corner gaps method defines a contour routing with one gap in each corner. 6. The equidistant gaps method defines a contour routing with equally spaced gaps. In our case, we will select the edge gaps method. Click on the More Details button to explore the detailed settings of the contour routing method. Click on the Source drop-down list to select the source layer of the contour routing. In our case, we will select the board outline layer. Next, we will set the tools required for our project through the Tool Magazine dialog. The Tool Magazine dialog allows us to perform a number of tasks related to machine tools, including the following. View a list of the tools required for the current project. View the tools currently present in the machine. Load the tool magazine. View or put back the tool currently present in the clamp. Pick up a tool with the clamp. Check the milling width or the milling depth of a tool. View the current state of the tool life spent. Replace an old tool with a new one. In the Tool Magazine dialog, assign each one of the required tools to one of the free holders as shown. Make sure that each tool life is sufficient for the PCB production. The machining view shows the tool type installed in each holder. A white color indicates that the holder is free. Before running the board production wizard, we need to install the tools in the corresponding holders, as specified in the Tools Magazine wizard. We start by installing the 1.5 mm spiral drill tool. Insert the spiral drill tool in the tool handler, as shown. Push the tool gently into holder number 1 until you hear a click sound, then remove the tool handler. You can easily find the required tool by checking the labels on the toolbox, which identifies the type, dimension, and location of each tool in the box. Repeat the same procedure to install the remaining tools in their corresponding holders, as shown. When you are done, check the tools to make sure they are firmly installed in their holders.